Alright, boys and girls, this is the third video on proportional relationships. This one hopefully is going to be quicker than the last couple because you guys are now becoming experts in identifying proportional relationships using tables and using graphs. So this video is going to focus on identifying a proportional relationship when we are given an equation that is describing a connection between two different variables, for lack of a better discussion. So just keep in mind that as we look at the equations, that our equations are still going to identify a common unit rate, or we will actually use the constant of proportionality within our equation, or it would be found in the equation if in fact the equation is proportional. So on the screen we have an equation that says 3x equals y. And so right now we're not sure if this is going to be proportional or not. So I'm going to actually use some of the other information I already know about proportional relationships, and I'm going to create a table. And by creating the table, I'm going to be able to have two things being compared, an x and a y, and then I can test to see if that table is proportional or not. So give me a second to get a table in here. Okay, so we have our table, so now let's go ahead and substitute in the information that will be helpful using this equation. So I'm just going to pick some values. Now, I know that if this is going to be proportional, it has to go through the origin, so I'm automatically going to pick a 0. And then I'm going to pick some other numbers. So I'm going to say let's pick 2, and I'm going to pick 3, I'm going to pick 5, and then I'm going to pick 8. And so all this means is it's kind of like a little rule table, right? So if I put 0 into this rule, let's see if I can find my pointer real quick. Alright, so if I put 0 in for x, alright, what's going to happen to y? So think about that being a little bit of a machine. And so 0 times 3 is going to give me 0. 2 in for x. 3 times 2 gives me 6. 3 in for x. 3 times 3 is 9. 15. And lastly, 24. Okay, so now I have a table. And now that I have the table taken care of, now I can start to compare and determine whether or not I do have a constant of proportionality. So the easiest way for me to look at this is to compare y over x. All right, so thinking about my unit rate of y over x, all right, and what is that going to take me to? So I can skip over 0, 0 because I already know what that's going to give me. But let's go ahead and look at the second one here. So 6 over 2, if I simplify that so that I have a 1, 6 divided by 2 gives me 3 over 1. And go to the next one, 9 over 3, simplifies to 1 on the bottom as that unit rate, 3 on top. 15 and 5, so 15 over 5, 3 over 1. And the last one, 24 over 8, 3 over 1. Okay, so hopefully you're noticing as we go through this that our equation actually makes a lot of sense, because the equation itself, I can find, right, the equation itself started with a constant of 3. No matter what the x is, it's going to be multiplied by 3 to give us our y. So that connection of that constant of 3 right here is also going to match up with the constant of 3 in all of the ratios that are found in the table. Okay, so that's one way that you can test your equation for proportionality. Another way to test for that proportionality would be to use your equation to make a graph. However, by finding the graph, you've already basically had to make the table. But I just want to show you what the graph would look like for that example of 3x equals y. Alright, so now we have a graph, and I am going to plot the points from the previous slide. So the very first point in my graph started with 0, 0 in my table. So 0, 0, plot the point. Then I substituted in 2 as my x, so I went to 2 and I got 6. So 2, 6. And then we did 3. 3 times 3 gave us 9, so it's going to be in between that 8 and 10. And then I did 5, 5 up to 15. And the last one was 8, and 8 gave me 24 in this equation. All right, so if you take a look there now, I hopefully have shown you a linear relationship. I'm draw my straight line the best I can through those points. All right, so I have a linear relationship, and I know that it's going through the origin, and I also can identify the constant of proportionality. So in my equation here, that 3 is the constant of proportionality. Okay, so I promised that this is going to be a video much shorter than the other ones. So as a quick way for you to identify whether or not an equation shows a proportional relationship, I'm going to simply suggest that you follow these 3 steps. 1, make a table of the values. Okay, so you're going to pick at least 5 values that are typically your x values, because your equation is going to be written in a format where you plug a value in for x and then you're going to get your y. So you're going to choose your x values, choose at least 5, and then substitute in each value for your equation. Then you're going to test those values that are in your new table for proportionality. So that's where you can use your cross products and test each pair to determine whether or not your cross products are equivalent. And you can also simplify each ratio that you have. I would highly suggest thinking about that y over x ratio when you are considering to get to that unit rate. And that way you are identifying not only the unit rate but the constant of proportionality that may very well be seen in the equation. And then if you're in doubt, all right, I would go ahead and take the table and put it onto an XY coordinate graph. And from there you will hopefully be able to identify whether or not your graph is showing a linear relationship that also goes through the origin 0, 0. Alright, so boys and girls, as you wrap up this video, you may pause and rewatch any of it, again, as usual, and then I have left you with 5 equations for you to test for proportionality. So you should be making a table that will include x and y's for each one of these equations, and then identify whether or not they are proportional. And hopefully through going in more depth with these 5 equations, you may come up with some other things you notice about equations that are proportional and equations that give a non-proportional relationship.